In today's video, we are going to see about what is the paging. So paging is nothing but it is one of the memory management technique. In the previous video, we have seen what is the memory management, what are all the activities in terms of operating system in memory management. So, what are all the topic we are going to cover is what is the basic concept behind the paging and hardware support, hardware architecture of the paging and how the production is done and how the shared pages are used in the paging hardware. So the paging, it is a memory management technique. It is divide the processes into the equal sized logical memory. So in the physical memory, it is divided into the frames. So in the paging, we are using the data structure as a paging table that map our logical memory into the physical memory. So the in the paging table, it contains the two major columns. One is the page number, other one is the frame number. So it mapped the page number to the frame number. So it mapped the addresses of physical memory to the logical memory. So suppose the frames in that page is not currently in the memory, means the page fault will occur. So in the paging, mainly it is a non-contiguous memory location. It is implemented using the paging. So the logical address space, it is a continuous memory location. The CPU generated the logical address space, and the memory management unit generate the physical address space. So using the paging concept, we can avoid the external fragmentation problem. It avoids the problem of varying sized memory chunks. So it divides the pages into the equal sized blocks called as a frames. That is, a physical memory is divided into the equal sized frames. The logical memory is divided into the equal sized pages. So the disadvantages in the paging concept is still we have the internal fragmentation. So already we know that what is the fragmentation. The wastage, there is a waste of space in the internal partition. So the internal fragmentation means the waste of space inside the within the partition. So external fragmentation means we have enough space to store the new process, but it is not in the continuous manner. So in the paging, mainly we use the address translation scheme. Here we are translating our logical address into the physical address. So the logical address into the physical address. The logical address space contains the page number and offset. The physical address space contains the frame number and offset. And also we are using one more important data structure is a page table. I said that in the page table, a page number and the frame number is a compulsory field. So we have an optional field like valid or invalid. That means that page is in the memory or not. And also the production field. Production means what is the access of the corresponding user, whether it is a read or write or update access. And also the reference field means suppose the pages is referenced or not. And the caching means that pages, the frequently used pages are stored in the cache memory, that is a TLB. That information also provided in the page table, that is an optional. And also if there is a corresponding page is modified by means, that modification specification also done in the dirty bit. So I said that we have an address translation scheme. Here the address generated by the CPU is divided into the page number and page offset. For a given logical address space 2 power m means, and the page size is 2 power n. So this is the paging hardware. Here the CPU generates the logical address space. So that page number is referred in terms of the page table. The page table contains the page number and corresponding frame number of the corresponding page. And the physical address, using the physical address, we can identify where the corresponding page is located in the frame. So this is the hardware structure of the paging. For example, considered you have a four pages in the logical memory. So the page table store that 4 pages and corresponding frame numbers. For example, the page 0 is stored in the frame 1, and the page 1 is stored in the frame 4, and the page 2 is 3, and the page 3 is 7. So that thing is represented in the physical memory. So in that, the logical memory is a continuous allocation and the physical memory is a non-continuous allocation. That I said that we have a address translation seem have the page number and offset. Offset means, so what is the page size of each location. So for example, it is a 4 bytes means it contains the 4 bytes. So the same logical and physical memory page size is equal to the 4 bytes. For example, here the zeroth page is stored in the frame number 5 means 5 into 4, that is a 20th memory location, the physical memory in the 20th location in physical memory, that 0th page is stored. So how that mapping is done in the using that 4 bytes pages in the paging example. And also we have the option of we can save the free frame list. So in the left side figure shows we have the free frame of 14, 13, 18, 20 and 15. After allocating the pages in the free frame, the right side shows the representation of pages in the corresponding frame. So this in so far I have thought what is the paging, basic concept of paging. So what are all the address translation scheme, how the paging hardware is represented with the page table entry, and paging production with the corresponding field. I hope you will understand the concept of paging and its implementation. Thank you.